Hello, welcome back to Economics. I'm Emmanuel. In this video, we continue our discussion on regression analysis. From past videos, we already established the fact that correlation is quite different, is distinct from regression. In correlation analysis, you're just looking at two variables, you're trying to understand the relationship, you're trying to look at the association between these variables, and trying to see if they co-move together. If as one is increasing, the other is decreasing, you're looking at the strength, sort of. But in regression, you are looking at the statistical dependence. It's constant with estimating. Actually, you're trying to predict one variable, a dependent variable, given the values of the other variable. In this case, this example, you are looking at consumption and income. So while correlation will just tell us how closely consumption and income is associated, how closely they are associated, regression analysis will help us predict consumption given income. So we will say if somebody is earning 2,000 naira on average, what do we expect the person to be spending on food items or whatever consumables? So in regression analysis, we are looking at estimating, we are looking at predicting the mean value of the dependent variable on the basis of the known or fixed values of the explanatory variable. So the dependent variable, the y variable, and the explanatory variable or variables, the x variable. So if we just have one explanatory variable, then we'll find ourselves discussing the simple regression. The simple regression is also known as the bivariate regression or the two variable regression. You have one dependent variable and one independent or explanatory variable. But when you have many explanatory variables, many independent variables, then we are looking at multiple regression. In this case, it's just a two variable case, the simple case, and consumption being a function of income. Okay, so here consumption is a function of income. Let's see why. But if we're to look at it from the multiple variable case now, we could say consumption is a function of, say, income, say interest rates, say wealth. Yeah, you can put in more variables. Okay, if interest rate is high, probably to encourage people to save, and if we assume that when not save is consumed, you'll consume less. So when we look at more variables that could be determining consumption in this case, then we're looking at multiple regression. But for this video, we'll be focusing on the two variable case, the simple regression. The simple regression. Back to our example of the consumption versus as related to income. This is just sort of hypothetical example, and we are looking at the entire population, families, and observing how their consumption varies with their level of income. So in this case now, we are looking at 20 families actually, 20 observations. So this is just 1, 2, 3, 4, 5, about 5 families per income level. So for those families in earning 1,000 naira, we have sort of that we can see what is spent on consumption. So this family here is spending below 1,000 naira. The family in the middle is spending about 1,000 naira. Some spending above. Those earning 2,000 naira as their income, say weekly income or monthly. However, let's just say weekly. We have the distribution of their consumption, and same for those earning 3,000 and those earning 4,000. So what's the advantage? Why we discussing regression? With regression, we can be able to estimate what to expect on average. On average, the mean value. We can estimate what will happen on average to consumption as income increases or decreases. So since we are considering average, in this case, we are seeing different consumption levels for families in this bracket, right? So on average, the family will sort of be consuming something around here, spending about 1,000 naira on consumption. Now this is the expected value of consumption for a family earning 1,000 naira. Here, for a family earning 2,000 naira, then the expected value is somewhere here on average. Some earning above, some earning below. So if you try to take the arithmetic average, you'll find the set somewhere here. So on average, the family earning 2,000 naira is earning is spending 1,500 now on consumption, and on and on and on. Yeah. So all these values, it can be called the conditional expected values. It is the expected value of consumption given income. So since our consumption is like the y variable and our income is the x variable, is the expected value of y given x. So in the case where x is 1,000 naira, the expected value of y given x is 1,000. Where x is 2,000, the expected value is 1,500, and on and on. So if we join these expected values, like we just in a way draw a line through this expected value, what we have there is sort of what we call the population regression line. Population regression line. So that's the goal of regression. To be able to predict what will happen on average. So we are saying that on average, as income increases, people spend more on consumption. No, this is not what happens to each family. In this case, let's look at this case. For those earning 2,000 naira, we see this family spending almost 2,000 naira on consumption, right? And now this another family earning 3,000, they are earning more, right? But this family is actually spending lesser than this family earning 2,000 naira. So probably there are other variables. Maybe this guy has more children and is spending more trying to feed them, something like that. But on average, we expect that as income increases, consumption increases. So with this, we can estimate our regression function. You know, this is just a graph. So you want to say like, okay, a family earning 1,500, what would their consumption be? They will try to start plotting graphically and that. But with mathematics, we can make things more interesting. We can try to estimate a sort of function. So here we know that the expected value of y given x. Now I'm trying to use y so that we're able to generalize. When I say y, I'm talking about consumption, and x, I'm talking about the income. The expected value of y is a function of x. And this function will take different forms. This could be linear, this could be exponential, this could be whatever. But for the simple case, since we are just laying building blocks in the study of regression analysis, we are looking at a sort of linear relationship, a linear function. And from elementary mathematics, we know that a linear function is something like where you have your y is equal to your mx plus c, right? This is your y-intercept, the value of y when x is 0, and this is your slope. So in the same light, we can estimate this population regression function using a linear form. And our population regression function from the population regression line, recall is population because we made it of all the families in the population we are studying, whatever we are studying. We took all the families, and even we selected from, okay, there are 20 families and we selected, let's say 10, we selected 5. Then the line we have won't be the population regression line, actually it will be the sample regression line. Okay, so estimating the population regression line in a linear form, something like this, then we can say that the conditional expected value of y will be our intercept coefficient, because we use beta 1 to denote, plus beta 2, this is the slope coefficient, times x. Okay. So this is just like the mx, and this beta 1 is like the c. So beta here represents the intercept coefficient. In this example we looked at, here we try to just draw it down and just say this will be our beta 1 in this case, and then the slope will be trying to find the change in consumption, that is the change in Y, over the change in income. Okay. So, and from economic interpretation, we can call this the autonomous consumption, because we expect families to consume even when they don't have any income. It's only normal to still consume. And here we're having our MPC, our consumption changes when they get additional income or reduced income. So with this, we have our population regression function, that's the PRF. Now we're introducing the concept of PRF, or the population regression function. To go to the sample, I mentioned earlier that if we just extracted from the population of study, then whatever we are doing, we just have sample. So instead of saying population regression line, you have sample regression line, population regression function, you have the sample regression function. So in the case of the sample regression function, because we are not making use of the whole families, like every family in this case, we're not considering every family in the population, then whatever we have will just be a rough estimate. We could get different sample regression lines depending on the families sort of we're able to find ourselves selecting. So whatever we do using the sample, from sampling and to estimate our sample regression function, they are all estimates. So if we were to rewrite this is our population regression function. Right. So if we were to rewrite it in a sample, we specify it as in a sample regression form, if we just selected from the population of study, then these conditional values now will be what we expect Y to be, the estimated expectation. We use arts, so we call it Y arts, just to show that we're estimating. And this is your parameters, the beta 1 and the beta 2. We also have arts. So they are estimators of the true values of beta 1. So yeah, if you made use of a sample, you probably might not have 500, depending on the points you pick. You could have above that. So whatever you have here will be your estimator of the true population parameter. So what we have here is the sample regression function. So having differentiated between our population regression function and the sample regression function, next we'll look at specifying these functions stochastically. Now, why the stochastic represents the specification of this function? I mentioned earlier that the regression function gives us what will happen on average, what we expect. So we'll find families above this line. So a family like this line is above the population regression line, while some families are below. And that is what the stochastic error term we use many times. Is the error term. Not as though there's a mistake, but just use error to incorporate whatever we can capture. So that is called noise term, whatever. So it's going to be the noise or error term. Yeah. So to specify our model stochastically, our true Y, all we have here is like the expected value of Y conditional in X. So now what will happen to Y exactly would be this expected value given X plus the error term, right? So for this family here, to be able to know what exactly this family here is consuming, is spending the portion of the income spent on consumption, we can get this error term, which our regression function will give us, plus the residual. It's also called residual noise error term, plus the error term. And so from here we see that this is in the population regression stuff. If it were to be the sample, then our true Y will simply be the Y at the estimator plus the error term. I want to put this here. So this is in the sample case. So we've established the fact earlier that we can't always incorporate everything in our models, no matter how beautiful the models are. Look at this consumption and income, and we can generate a lot of things from the MPC and that, but you probably won't put the number of children each family has, or everything, or the wealth or interest rates, the model could be so much complex. So trying to simplify these models can help us gain lots of insights. When we simplify that, those things that we don't cover can be captured in the error term. So that's just about that. And we see that specifying it in this sort of regression form, this deterministic form, doesn't like cause problems, because we expect, if we take expectations of this, the expected value of the true stuff, expected value of y is similar to this, is the expected value of this plus the expected value of the error term. And as we are going to learn later, the expected value of the error term, some assumptions is that it should be 0, so that at the end of the day, the expected value of the true stuff is still equal to what you are estimating. So that's the idea of linear the stochastic specification. It helps us incorporate those things that probably theory couldn't capture, or even when theory helps us capture, we can't measure correctly. We can't always measure correctly. So there's sort of this intrinsic randomness in human that can always be captured in models. Now, finally, we talked about the simple linear regression. The simple case we'll be looking at in this video tries to specify a linear form. Now, this linearity could be in 2 forms. You could have linearity in relation to their parameters, and the parameters, beta 1, beta 2, like parameters. Or you could have linearity in respect to the variables, that is the x, the x1, the x2, depending on the number of variables you have. So in this case here, we just looked at, let's say we looked at y is equal to beta 1 plus beta 2x. In this case now, we have a sort of linear equation. It's linear both in parameters and linear in variables. It's linear in variables because the variables we are looking at here the power isn't greater than 1. If you have something like y is equal to beta 1 plus beta 2x2, now this is not in terms of variables, it is not linear. But when you look at parameters, it is linear. It's linear in parameters because your beta 1 isn't raised to the power of 2, it's just raised to the power of 1. If it's raised to the power of 3, then it becomes non-linear. So let me give another example where y is equal to, say, beta 1 squared plus beta 2x, something like this. So this case is linear in variables, just at the power of 1, but not linear in parameters. So that's just a distinction between linearity in parameters and linearity in variables. And for regression analysis, at least at this basic stage, when we mentioned linearity, we are specifically talking about linearity in parameters. For this case that is non-linear in variables and linear in parameters, we can still estimate this using regression. You can just take log of both sides, and at the end of the day it becomes linear. But when you have this, you have a non-linear regression and you need advanced econometric techniques. Okay, so this brings us to the end of this class. We are still actually looking at the introductory section of regression analysis. In future videos, we'll be talking about different techniques like the OLS, the ordinary least squares, used in estimating a 2-variable and even a multiple regression case. So please don't forget to subscribe to this channel if you're not done. This video, if you really enjoyed it, like it. For your comments, if you have questions or whatever you want us to do, please put them in the comment section. We'll be happy to see them and respond to them. Thank you.
Hope you enjoyed the video you just saw. If you want more of our videos, please make sure you subscribe to the channel and click on the notification bell. Now, there is a way to enjoy to make the best of our YouTube channel, which is to go to the playlist section of every video or of every topic. So what you have to do is just type Econometrics on YouTube, when the page displays, make sure you subscribe. A bell button appears immediately, so you click on that bell button. Then go to the playlist section. So you're going to see videos, playlists, description, and all of that. So just go to the playlist section, and whatever topic you are looking for, look for the playlist and click on the video. Now our playlists have their classes, have the classes arranged in a very chronological manner. So if you want to see a class on ISLM, so it starts from the beginning, the simple ones to the difficult to the complex ones. So if you want to see a video on, let's say, elasticity of demand, so you start from what is price elasticity, so from there then to the basic ones, and on and on. So I'm just telling you that in case you really want to make the best of this YouTube channel. And there's also one thing that I want to add, which is that our YouTube classes may not be enough for you. You may want a regular interaction with the tutors and all of that. So what you just have to do is to check the description of the video. You are going to find a WhatsApp link. So but before you do that, I really have to tell you that clicking that link is going to lead you to one of our schools. It's going to lead to some of our schools. So we have MOGE School of Economics on WhatsApp, and we make use of our YouTube channel to run the groups. So the classes are paid for, so you're meant to pay for them. So to join our Econometrics school, so that is 2,500 naira per month, and to join our Microeconomics or Macroeconomics schools, so that is 2,000 naira per month. We also have we don't have schools of mathematical economics, because microeconomics has its mathematical aspects as well as macroeconomics. So the mathematical aspect of macroeconomics is treated in the macroeconomics school, and the mathematical aspect of microeconomics is treated with the microeconomics school as well. So I'll see you next time. Thank you very much for watching.